Welcome back. This is Mrs. RRubright with the second half of our lesson on 11.7. All right, so the next problem, solve a multi-step problem. You're using the funnel shown to measure the coarseness of a particular type of sand. It takes 2.8 seconds for the sand to empty out of the funnel. Find the flow rate of the sand in milliliters per second. So it's saying it wants milliliters per second. So 1 milliliter is 1 cubic centimeter. So if we find the volume in centimeters cubed, that is a milliliter. So we don't even have to really convert much at all. So let's see. All right, so the volume of this, 1/3 area of the base times the height. We have the height as 6. 1/3 area of the base, pi r squared. Our r is 4. 4 squared is 16. So 1/3 of 16 pi times the height of 6. All right, so 6 divided by 3 is 2. 2 times 16 is 32. So we're dealing with 32 pi milliliters, right? And we want this in milliliters per second. So it takes 2.8 seconds for it to empty out. So divided by 2.8. We don't want 2.8, we want 1. So we're just going to divide by 2.8 on the top and bottom. Would give us that per 1 second, right? So 32 times pi equals, divided by 2.8 equals, and we would get 35.9 milliliters per second. Okay? Our next one, find the volume of the cone at the right. Round your answer to 2 decimal places. So the volume of the cone is 1/3 area of the base, pi r squared, times the height of 5.8. What is our radius? Well, we need opposite. We have adjacent. Opposite and adjacent go with tan. Tan of 40 equals opposite over adjacent. So our r squared is going to be 5.8 tan 40 squared, right? So 40 tan times 5.8 equals squared times pi equals times 5.8 equals divided by 3 equals, and I got 143.86. 143.86. All right, they're prematurely rounding. You shouldn't do that. A right cylinder with a radius of 3 centimeters and a height of 10 has a right cone on top of it. It's like a birthday hat on top of it, with the same base and height is 5 centimeters. Find the volume of the solid, round to 2 decimal places. Well, the volume down here, area of the base, pi r squared, or 9 pi, times the height of 10. Up here, we have 1/3 area of the base, which is 9 pi, right, pi r squared, times the height of 5. So 9 divided by 3 is 3, so 3 pi times 5 is 15 pi. So we have 15 pi up top plus 90 pi down below. We have 105 pi, which is approximately 329.87. 329.87. They wanted us to round to 2 decimal places. They, once again, prematurely rounded, so they were off slightly. All right, and then try this one on your own. I'm going to pause this to give you a second to try it. And here is our last question. What if in example 5, suppose a different type of sand is used that takes 3.2 seconds to empty out of the funnel? Find its flow rate. All right, so we're going back to example 5. So once again, in example 5, we had our volume is 1/3 area of the base times the height, which was 1/3. The base was 16 pi, and our height was 6. 6 divided by 3 is 2, so we had 32 pi. So we had 32 pi, and our flow rate has now changed to 3.2 seconds. So divided by 3.2. 32 divided by 3.2 is 10. So we're going to have 10 pi, or 31.42 is our new flow rate. All right, and do not prematurely round. All right, so that is everything on our lesson on 11.7, the volume of pyramids and cones. I hope you enjoyed the lesson. Please like and subscribe and have a great day.